As always, I started by writing down the calculator answer for each of the problems. A reminder, all digits in the coefficient, the part that comes before the exponent, all digits in the coefficient of a number in scientific notation are significant. So we can immediately determine the number of sig figs in the numerator as 4 sig figs. The denominator has 2 sig figs. The least number of sig figs is 2, so we write our answer with 2 sig figs. We have to round up. Our correctly reported answer is 62. Overall, question 7 is a division problem. We need to determine the number of sig figs in the numerator and the number of sig figs in the denominator. Let's look at the numerator, a subtraction problem. So we need to convert these numbers to the same coefficient. We're going to convert the second number to the higher exponent, 2. To go from 10 to the first to 10 to the second, that means we need to multiply by 10. We can't change the overall value of the number, so if we change the exponent by multiplying by 10, we need to divide the coefficient by 10. We've lined up our decimal points so we can see how far we can go in decimal places. So we can see we can go to the 10th decimal place here, which results in a number that's going to have 2 sig figs. So the numerator, the result, has 2 sig figs. Now let's look at the denominator. Addition of numbers in scientific notation. We need to match the exponents in order to determine the number of sig figs in the result. We want to convert the exponent in the second number to 10 to the 5th. So we need to multiply by 1,000. Now we cannot change the value of this number, so if we multiply the exponent by 1,000, we need to divide the coefficient by 1,000. We've rewritten the result, lined up the decimal point, and we see that we can't go beyond the second decimal place, which means that our result is going to be a number with 3 sig figs. So our overall division, we have a number with 2 sig figs divided by a number with 3 sig figs. We're limited to 2 sig figs in our final result. The first number to be dropped is greater than 5, so we round up. We add 1 to the preceding decimal column. Our result is thus 0.0017. In this problem, we see we have a multiplication between a number with 4 sig figs and the result of this calculation. So we need to determine how many sig figs are in the result of that calculation. This is addition, so we need to match our exponents so we can determine the appropriate number of sig figs. To go from 10 to the 5th to 10 to the 8th, we need to multiply by 10 to the 3rd, or 1,000. If we multiply the exponential part by 1,000, we need to divide the coefficient by 1,000. All right, so we've lined things up, lined up our decimal point, and we see we can't go beyond the second decimal place, and this results in a number with 3 sig figs. So we have a number with 3 sig figs multiplied by one with 4 sig figs. So we can only use 3 sig figs in our answer. The first number we drop is 2, so we round down, and our final correct answer is 8.01 times 10 to the 12th.